Thank you for coming this evening. I'm Gail Grunwald. I'm Executive Director of Tip of the Mitt Watershed Council. We're headquartered in Petoskey. And I am thrilled to bring you tonight's presentation called The Three Tenors of Climate Change. So since 1979, the Watershed Council has been the lead voice in Northern Michigan protecting our waters. We accomplished this goal through water quality monitoring and research, restoration actions, policy and advocacy, and education. We work primarily in Northern Michigan, but you'll also find our staff in Lansing and Washington, D.C., defending the laws that protect our water resources. 3 years ago, the Watershed Council Board and staff adopted a position statement incorporating climate change into all of our watershed protection and management work, including restoration and outreach and education. We work to ensure that our waters are resilient to the impacts of our changing climate. We also are committed to raising awareness about the climate disaster that is underway so that all of us can take the actions needed to be a positive influence in our future. This presentation represents an outreach effort that brings international knowledge and expertise to Northern Michigan to help us all understand more fully what is in front of us and to take action on behalf of our planet. We hosted a luncheon earlier today where our three tenors, Chip Duncan, Hernando Garcon, and Ben Santer, shared when, how, and why they teamed up to bring their climate story of art, science, and global health activism to audiences across the nation. We are incredibly lucky that they have brought their story to Northern Michigan. Tonight we have a unique opportunity to see and hear their presentation of these remarkably talented and committed climate warriors. A longtime Watershed Council board member, David Krause, has partnered with fellow film producer Chip Duncan, one of our tenors, to produce many films over the years. David knew of Chip's association with Dr. Garzon and Ben Santer and approached me to host a presentation of the Three Tenors. And although David can't be here tonight, he and his wife Teresa generously sponsored our use of this incredible facility. We're grateful for not only that support, but his connection to this story that we're presenting tonight. The Three Tenors of Climate Change are all on the board of directors of a group called the Juneau Icefields Research Program. Their work there led them to traveling the country sharing their message. So although they are not going to be singing for us tonight, they will be sharing their remarkable diversity of experience, expertise, and perspective toward their common goal, which I'm quoting, improving public understanding of the science and impacts of human-caused climate change. Here's my short introduction of all three of them. For more information that, quite frankly, will make you wonder what you've been doing all your life, do a quick Google search on the three of them. They're all remarkable. So we're going to start with Chip Duncan. He's a film producer, as I mentioned, but more than that, he's an international citizen and philanthropist. He's a witness to the changes in the world, and through his art, he brings us along with him. He's going to start us off tonight. Dr. Ben Santer is an atmospheric scientist at the Lawrence Livermore National Laboratory in California. He's a world-renowned climatologist. And in 1995, he contributed to the historic conclusion on climate change, quote, "The balance of evidence suggests a discernible human influence on global climate." The first time that was stated. He's going to share how those 12 words changed his life, both in 1995 and today. His work identifies and shares the human fingerprints on our climate. Dr. Hernando Garcon is an emergency medicine physician at Permanente Medical Group in California. And as I've come to know in the last day or two, he is not your typical emergency room doctor. He travels domestically and internationally, serving as a disaster medical relief doctor, starting in 1995 with the Oklahoma City bombing through Hurricane Maria in Puerto Rico in 2017. He also serves as a witness to the global impacts of climate change. My personal thank you to the three of them for making the space in their lives to be here. Two of them came from California, the other one got off a plane from Ethiopia. It was quite an effort to get to Petoskey yesterday for this presentation today. So thanks to them, thanks to you for coming, and off we go.
Thank you very much, Gail, and thank you to the Watershed Council for having us here. My name is Chip Duncan. As you can tell from my voice, I do not sound like a tenor. So for better or worse, I'm struggling with a cold, and I did come in last night from Ethiopia. So We'll see if the combination of jet lag and cold, it should be quite an interesting presentation. I did manage to stay away from the wine at dinner, so I'm trying to keep it together. At any rate, my career is really one that's defined primarily by doing documentaries for public television. I also am a still photographer. And in 1991, I made my first trip to Alaska. And at that time, my first film there was a film about bald eagles for Discovery Channel. And then shortly after that, I rafted for the first time down the Tachin-Chini River. And the Tachin-Chini River goes through the St. Elias Mountains. There are about 10,000 glaciers in Alaska. And that was my first exposure to glaciers. I walked on the Mendenhall Glacier in Juneau. I'm guessing there's a handful of people. In fact, I'll even ask, how many people here have walked on the Mendenhall Glacier? Quite a few of you. Well, my exposure to the Mendenhall has been significant. In fact, you'll see the Mendenhall in some of the presentation tonight. But that was my first exposure to glaciers. I've since gone back virtually every summer since that time, have documented the Alsek River 7 or 8 times, the Tachin-Chini River 4 or 5 times. I've also worked in the Arctic, and then more recently, in the last decade or so, I've been a member of the Juneau Icefield Research Project Board. And the Juneau Icefield Research Project is where I first met Ben Santer. I met Dr. Garzon, Dr. Hernando Garcon, for the first time in Haiti doing earthquake relief about 35 hours or so after that major earthquake. But the Icefield Project is one that brings us together. And so I'm going to just play a few slides here to give you a little bit of background on that region in Alaska while I'm talking. And it's primarily an area where my access has been on river rafts. I've worked with a company called Chilkat Guides and have gone down several times down. Over the last roughly 30 years, I've been able to stand in the same place on several occasions and document the decline in glaciers. I am certainly not a glaciologist and not an expert on what happens with ice, but as a documentarian, I've been able to see some significant changes. The Icefield Project, to give you a little background, is a student project that starts in Juneau. Every summer since 1947, there's about 30 to 35 students and about 15 faculty members. They go hiking up the Mendenhall Glacier, and then over a 7-week period, they ski, or in some cases walk across the Juneau Icefield and do climate research. And they've been able to do climate research in the same locations since '47. And because of their work, they now have the second longest running continuous climate records on Earth. Alaska glaciers in particular are struggling, but glaciers everywhere are struggling to survive. The Himalayan glaciers, the meltwater from those glaciers feeds about 2 billion people right now, and both the Chinese and the Indian governments are doing a lot of documentation of those glaciers. The Juneau Icefield Research Program is the one that's primarily doing the icefield, and then there's the Arctic Institute in Canada, which is also doing a lot of measurement of the decline of the glaciers. So what I'm going to do tonight is play 2 clips from films that I'm working on, and then I'm going to more or less MC the evening, and after these couple of clips, I'll bring Ben out, and then eventually Hernando will come out. Ben's focus is on the science. He's a climatologist and has worked with Lawrence Livermore Labs for more than a generation. So he'll be able to present you with the scientific evidence for human-caused climate change. And Hernando, Dr. Garzon, he will be able to provide you with information on the human toll of climate change. And in particular, Hernando will look at human migrations that are related to various storms and sea level rise. But also, he'll discuss the impact of climate change on the poor. And that is, as we look at the world today, the poor in the world who are struggling the most and who are suffering the most. And that's an area of focus for both Hernando and for me. The work I do in Africa, for example, I was just with the Maasai people in northern Kenya less than 2 weeks ago. They're struggling with the worst drought they've seen. And the gentleman I was with was 40 years old, the worst drought he's seen in his lifetime. It is having a major impact on wildlife, a major impact on livelihoods. So as we get into the Q&A portion of the evening, feel free to ask questions that are as global as you would like. We're not just focused on glaciers. In fact, Ben's talk will focus much more heavily on sea level rise and on satellite measurements. So we'll open it up to questions. I'd like to begin with a clip for a film called Meltdown. As I mentioned, I'm primarily a documentary filmmaker. The film Meltdown is something we started working on a few years ago. We've done quite a bit of shooting in South America and North America primarily, and the clips that you'll see from Meltdown will give you a sense of where the film is headed. It's not finished yet, so you're just looking at a trailer.
95% of the glaciers in Alaska are retreating and thinning, but glaciers throughout the globe are retreating and thinning.
The majority of the glaciers, the normal ones that aren't surging, they're almost unanimous in their behavior. They're losing ground, they're losing mass, they're getting thinner, they're shrinking.
They're losing ice. Basically, the glaciers are becoming smaller. The smaller glaciers often retreat. They're thin enough that a small loss of ice means the area gets reduced.
It's really clear that the mountain glaciers and ice caps of the world are in a state of negative balance. They're unhealthy. What's going on right now is unsustainable for them.
More than 2 billion people rely on glacial meltwater for drinking and agricultural use. What happens when the ice is gone?
What would an ice-free Arctic look like? What would that mean? Human-caused climate change is not some future hypothetical. We're already seeing that play out.
When people say, is climate change real? The first answer is yes, climate has always changed. And if climate wasn't changing, something would be wrong. Then there's the question of, are humans involved with this? And certainly we are.
Our very accurate GPS surveying shows that the elevation or the height of the glacier in the high areas is actually decreasing in spite of more snowfall. We feel that this is consistent with the effects of carbon dioxide on the atmosphere.
The future? Rising sea levels, extreme weather, acute water shortages. Solutions begin with dialogue.
When we first came down, the face of the ice was right about where we're standing. And you can see how far back it's gone. And not only has it gone back, but it's come down. It's shrinking down.
Accessing glaciers is challenging. The obstacles considerable.
This is not an ideological issue. This is a science issue. Science tells us a very, very clear story. We have changed the chemical composition of the atmosphere, and those changes in chemistry are changing the climate of planet Earth.
We can't isolate the natural world from the rest of our social systems. So this is going to have a huge cost eventually, and I think that's something that we don't appreciate right now.
We need to broaden our scope and understand that we live in a dynamic environment, and that perhaps what's convenient for us may not be convenient for the Earth.
We may not want to hear the message. Some of us may not want to believe it, but that doesn't change the facts.
As you can see, there's a lot referenced in climate change. There's sea level rise, there's storms, there's any number of challenges, insect populations. In fact, I was speaking with someone here in Michigan last night about the tick population here and how it's dramatically been impacted. I live in southern Wisconsin, and we're seeing ticks in February now, where previously we wouldn't see them until June. So there's all kinds of changes associated with climate. The glaciers happen to be my focus, and so the next clip I'm going to show you guys tonight is from a film that's been completed and is now in distribution to schools. To give you a little background on the filmmaking process, this film, Meltdown, when we went about pursuing the making of that film, we decided to work completely independently. The upside of that is that we have editorial and creative control, and we're not beholden to anyone who has any agenda other than fact. The downside is that when we're working independently, oftentimes we do struggle with funding. So that film is a work in progress. The next one I'm going to show you, we produced on spec, completely on our own. It's called The Life and Death of Glaciers. And the clip I'm going to show you is from part 2 of the series that's been in distribution now for about 6 years to middle schools and high schools all around the country. During the evolution of the distribution of that film, we have changed the language in the film now for the 3rd time. When we released it in 2011, we used the term global warming. Then the political pressures changed pretty dramatically, and we went in and did some updating to the film, but we also changed the language back to just climate change. And then after the last IPCC report, we went back in and changed the language back to global warming. And it's become so imminently clear that the science supports the human-caused warming of the planet that we're very comfortable with that decision today. So this next clip from Life and Death of Glaciers is actually from the death of a glacier, which is part 2 in the series. And I picked this clip because it's rather informative. It's only 5 minutes long, but it'll give you a little bit of background that's specific to this region of Alaska and Western Canada that we talked about.
The beauty and wilderness of the St. Elias Mountains may be unsurpassed, and what this landscape lacks in people, it makes up for in its wildlife and glaciers. Thousands of glaciers run through the valleys or hang from the upper reaches of these enormous peaks. The vast majority of glaciers here are retreating or growing smaller.
95% of the glaciers in Alaska are retreating and thinning, but glaciers throughout the globe are retreating and thinning. If you look at the climate records in Juneau, only go back to the mid-1940s, and we could say since that time it's definitely been warming up, and the glacier's been retreating pretty dramatically.
This place we're standing now would have been under ice in the 20s and 30s. So in just 70 years, the glacier has retreated that distance, and the lake has come out. This lake is less than 100 years old. We have that visual. The glaciers that have low accumulation areas are not doing well with warming climate. They get more rain than snow annually, and their winter snow doesn't last through the summer. So that's the deficit spender for a glacier.
We're increasing the concentration of greenhouse gases in the atmosphere, and that's going to lead to warming, and that's going to have a negative impact on glaciers. And so, anything that people can do in their lives that decreases their carbon footprint is going to be good for the glaciers and good for the polar bears.
These glaciers that emanate out of the St. Elias Mountains certainly are going to be susceptible to current warming trends that we're seeing. And they're already retreating rapidly.
The challenge is in letting people know that this is not some future event. It's not some hypothetical event. It's not some distant event. Human-caused climate change is affecting us now. We see the signal emerging from the noise of natural climate variability. And we see that signal not just in remote locations, the Arctic, the Antarctic, high alpine environments. We see it close to home too.
What might happen to the Alaska glaciers over the next 50 to 100 years is hard to predict, but I would say that the overall pattern of general mass loss will be sustained. A majority of the glaciers, I think, will probably lose mass.
So any way a glacier gains mass would be called accumulation. Any way it loses mass would be called ablation. And if you track those over the year, then the balance of those is called the mass balance.
At first it sounds like it's something complicated, but then you think about it and balance is kind of like weigh. And so you're just sort of balancing the glacier's mass inputs and outputs like you would your checkbook with money. So we measure how much it snows and how much it melts.
So if you have more snow than you have melt, you've got a positive balance or a healthy glacier. If you've got more melt than you have snow in the winter, you've got a glacier that's a negative balance. So we can get a regional picture of glacier mass change from space. And then a lot of us are working with ground-based measurements with very simple, old-fashioned techniques, actually. Digging snow pits in the late spring to look at how much accumulation there's been over the winter, and going in the summer and measuring stakes that are drilled into the ice that simply melt out of the ice. And by measuring the height of these stakes at strategic locations around the glaciers we're studying, we're able to see how much ice is lost. It's really clear that the mountain glaciers and ice caps of the world are in a state of negative balance. They're unhealthy. What's going on right now is unsustainable for them. We can see glacier retreat happening in places where the glaciers are already quite small or thin near the margins, because then you see them backing up. But what's happening here with these big glaciers is that they're just thinning and they're down wasting. So they're so big, we're not seeing them retreat yet, but they're losing lots of mass just by thinning. And that's a little bit harder to see just on an observational basis.
In the St. Elias region, the story of most glaciers is similar. Bart Henderson named the Walker Glacier during his first rafting trip here in 1976. The reason was simple. A person could walk onto the glacier from the shore of the Alsek River. Today, the Walker Glacier has receded more than a mile from the river's edge. Its elevation is reduced by hundreds of feet.
When we first came down, the face of the ice was right about where we're standing. And you can see how far back it's gone. And not only has it gone back, but it's come down. It's shrinking down. And so the height of the ice is very different than what it was 30 years ago. So all these glaciers are receding.
Bart Henderson, who you saw there at the end, he's the gentleman I've rafted with now since 1991. And his eyewitness testimony goes back considerably further, all the way into the 70s. The last shot you saw there of the Walker Glacier was the last time I was there was 2013. I'll be there again in 2020. But you can I've seen photos from other people who've been there, and you can no longer see the glacier from the river, where in 1979 it came all the way down to the river. So that's just one of many stories up there. The Lowell Glacier is another one we've documented heavily, but the phenomenon tends to be the same. Now, what's interesting is there are people who, for any number of reasons, whether they're political or simply not interested in getting the knowledge to understand climate change, there's a lot of people who use the word belief, and they say, I don't believe in global warming, or I don't believe in climate change. So part of our job is to provide you tonight with as much evidence as we can. And the scientist among us is Dr. Ben Santer. So I'm going to turn the stage over to Ben at this point. But a little background, I met Ben for the first time about 8 years ago. I was part of the Juneau Icefield Research Project board at that time, and Dr. Hernando Garcon, who's with us, he and I were going together to the icefield to do some lecturing as faculty, but also we both worked with the program over time. So we were on a helicopter in Juneau making our first journey there, and Ben had been invited by the field team there to come up and lecture. So our first encounter with Ben Santer was on a helicopter on our way to the Juneau Icefield. And of course, we had a lot of common ground and shared a lot of ideas. But it wasn't long after that Ben and I went back a second time and then a third time, and we found ourselves lecturing to the students at night in the lecture hall. And I'd be talking about international issues primarily, and Ben would be talking purely about science. And so finally we started to merge our lectures together. And then eventually we decided, well, if we're going to speak together, what we really need is a global health component, and that's where Hernando comes in. So Ben's going to give you what I consider a really fascinating presentation. He'll talk about the 12 words that changed his life. But without further ado, I'm going to introduce Dr. Ben Santer from the Lawrence Livermore Labs.
Good evening, ladies and gentlemen. Thank you for coming out here tonight. These are not just two pretty pictures. This is the very famous blue marble, a picture from NASA where they put together cloud-cleared images. Bless you. And the picture on the right, I've superimposed on the blue marble satellite-based estimates of the warming of Earth's atmosphere since 1979. We'll get back to those satellite measurements in a bit. But the question facing us is, what kind of world do we want to live in? What kind of world do we want our kids and grandkids to grow up in? It's like the Matrix, you know, the red pill or the blue pill, the blue world or a very different world. That's the choice facing us now. Why should we care about this stuff? To me, this figure encapsulates why we should care about the issue of climate change. And it's from the most recent National Climate Assessment. This came out last year. This is an assessment that is mandated by Congress, has to be provided to Congress every 4 or 5 years. And these are measurements of atmospheric CO2 trapped in bubbles of glacial ice, made at a number of stations in Antarctica. People drill down deep into ice, they extract the cores, they measure the carbon dioxide and other greenhouse gases trapped in the air at the time the bubble was formed. This goes back, this particular slide here goes back 10,000 years and shows you where we are now at over 400 parts per million carbon dioxide in the atmosphere. That's probably unprecedented in the last 3 to 5 million years. So we are in uncharted territory, and that's one of the reasons for concern, this very rapid increase in the rate of heat trapping carbon dioxide in the atmosphere. Another reason for concern is the future. These, again from the last National Climate Assessment, are estimates of sea level rise from tide gauges from 1880 through to about the late 1970s. More recently, we've measured sea level from space using this technique called satellite radar altimetry, where we literally bounce radar off the surface of the oceans and can measure very, very accurately the height of global sea level. So this information tells us that since 1880, global mean sea level has risen by about 8 inches. A task force, a US task force on sea level rise, put together 8 different projections of emissions change and understanding of sea level from paleoclimate. These are their 6 best estimates from low to high of what we're facing over this century. Even at the low end, we're likely looking at least 1 foot of global mean sea level rise. At the high end, 8 feet. That's a different planet. So again, the message is, we have to decide, based on how much energy we use, the mix of energy we use, which one of these pathways we're going to follow. And the outcomes for the 21st century are starkly different and should be of concern to all of us, in my opinion. So Chip and Gail have already given a little bit of an introduction to me. Let me give a little more. I've been at Lawrence Livermore National Lab for 27 years now. I'm an atmospheric scientist. My job is to study the nature and causes of climate change, essentially using pattern recognition techniques that many electrical engineers use. My education, I'm a US citizen, but my folks moved to Germany when I was 11 years old, and I wound up being the only American at a British Army school, the only kid who couldn't play soccer, rugby, and cricket. So learning how to play soccer was a survival skill and was good training for my later years in climate science. Gail and Chip both mentioned this. In 1994, I received a phone call that changed my life. I was asked to be the convening lead author of 1 chapter of a report by the Intergovernmental Panel on Climate Change. So this is a panel set up by the World Meteorological Organization and the United Nations Environment Program in 1988. Their role is to advise the governments of the world what we know about the physical climate system, what we know about likely impacts of climate change, and what we know about possible mitigation and adaptation strategies. And the person who called me said, Ben, There's one chapter of this report, Detection of Climate Change and Attribution of Causes. We would like you to be the convening lead author. You should do this, Ben. It will be, quote, a real feather in your cap. Little did I know what the consequences would be of saying yes. But eventually this road, after 1.5 years of assessing the science, led to the beautiful Palacio de Congresos in Madrid with this beautiful mural on the front of it. And for 3 days in November 1995, the governments of the world congregated in Madrid, and our job was to come up with some assessment of the then available scientific evidence. That was this report, and here are the infamous 12 words engraved on my memory. The balance of evidence suggests a discernible human influence on global climate. I had no idea that those 12 words would change my life, and I'm going to tell you a little bit about the personal lessons learned, 6 of them, from this experience back in 1995. The first lesson was the power of words. I had no idea how powerful words could be. Think about it. This isn't Eureka, there's water in the bathtub, we understand everything. The balance of evidence suggests. And in Madrid, we spent literally 3 days discussing the nuances of language. Should it be balance of evidence, strength, weight of evidence, preponderance of evidence? In a legal sense, each one of those things has a different interpretation. And this report was not just a report in English, it would be translated into Chinese and German and French. And would the meaning of the word be the same in each of these languages? Who knew that words could be so powerful? It was a profound lesson for me. And again, what was the right verb here? Was suggests to weak? Should it be indicate? Should it be demonstrates? And the qualifier on the human influence, we had literally hours of discussion about that one word. Should it be significant, detectable, identifiable, measurable, appreciable? The power of language, that was really a profound lesson for me. Lesson 2, do the science necessary to address the criticism. So after the balance of evidence statement comes out in November 1995, a lot of powerful people didn't like it. They made my life pretty miserable. I was investigated by Congress. There were calls for my dismissal with dishonor from my position at Lawrence Livermore National Lab. One gentleman circulated an email in which he said that I was about to be indicted by the Hague International Court of Justice for, quote, falsification of international scientific documents, unquote. I was accused of scientific cleansing, of purging from this document all discussion of scientific uncertainty. This was at the time that ethnic cleansing was going on in Bosnia. Nothing in your scientific training prepares you for that. You're prepared to defend the science that you do, the appropriateness of your research methods, your findings in front of your peers, but not your humanity, your honesty, your integrity. So one criticism back then in 1995 was you folks don't look at other hypotheses. You have blinkers on. You're just looking at human influence. You never explore whether other alternate hypotheses might explain this kind of warming. So this, for example, is an estimate of global surface temperature change from the NASA Goddard Institute for Space Studies in New York. About 3 or 4 other groups in the world produce these kind of estimates, and they show warming now of roughly 1.1 degrees Celsius since 1880, and you can see that there are some interesting bumps and wiggles which we like to understand. But one criticism of the balance of evidence finding was this warming is all due to some uptick in the sun's energy output. And one message for tonight is we look at those kind of things. We look at whether changes in the sun's energy output could plausibly explain this warming. So let's look at the sun explains everything hypothesis. This is a sort of Simpson's view of the Earth and the sun, obviously not drawn to scale. Imagine if these solar enthusiasts were right and all of the warming that I just showed you were due to some more active sun. the sun's energy output increasing over the 20th century. What you would expect to see then is heating throughout the entire vertical extent of the atmosphere. Again, not drawn to scale here, but you'd expect to see heating from the top of the atmosphere right down to the surface. What do we actually see? Enter the satellite data. Gail mentioned these. I've spent about 30 years looking at these beautiful satellite-based measurements of the temperature of the atmosphere. And what you're seeing here is a slice through the Earth's atmosphere from the South Pole to the North Pole, and from the bottom of the atmosphere right to the top of the atmosphere. What do these satellites do? They look at the microwave emissions of oxygen molecules, and those microwave emissions depend on the temperature of different layers of the atmosphere. By measuring at different microwave frequencies, you can literally take the temperature of different layers of the atmosphere. So the kicker here is the satellite observations don't show warming from the bottom of the atmosphere to the top. They show this very curious pattern of cooling up high and warming low down. And the largest warming is where we've had the largest decrease in Arctic sea ice extent. Arctic sea ice has decreased in terms of its September minimum by about 40% over the 40 years we've been measuring Arctic sea ice extent from space. So this is where, over the Arctic, we see the largest warming of the lower atmosphere. This pattern of warming low down and cooling up high is fundamentally inconsistent with the sun explains everything hypothesis. But if you look at satellite human influence simulations where we increase CO2 and other heat-trapping greenhouse gases, you see a very similar pattern to what we actually see in the satellite data, warming low down and cooling up high. And this curious pattern was predicted over 50 years ago by a guy named Tsuki Manabe at the Geophysical Fluid Dynamics Lab in Princeton. He performed very simple simulations with climate models and saw when I increase CO2 in a climate model, I more effectively trap heat lower down in the atmosphere, and the upper atmosphere has to cool because less heat is getting higher up into the atmosphere. Tsuki Manabe was right. And the model simulations with human influence, the satellite data, fundamentally contradict the sun explains everything hypothesis. Here's another piece of evidence. These are satellite measurements from space of the sun's energy output. We've monitored the sun's energy output since about 1979. Here you see this nice, roughly 11-year sunspot cycle. More sunspots, more solar energy output. But you can see that over the time we've monitored the sun's energy output from space, there's been no increase in that energy output, but global mean temperature has increased. Again, this is a fundamental difficulty that you face if you posit the sun explains all surface warming. So lesson 2 is do the science necessary to address the criticism and look at all the data. We can't put on blinkers. We can't have folks just looking at one tiny preferred slice of evidence. It doesn't work that way. If you have a voice, use it. One lesson I learned back then was I was not just a climate scientist. I had to explain to people in plain English what we did, what we learned, and why it mattered to them. I couldn't just retreat to my office when folks in Congress were investigating me and hope that the bad stuff would go away. Hoping that the bad stuff would go away is a singularly poor survival strategy. So, I had to learn how to testify in front of Congress, which is this picture here in front of the now defunct House Select Committee on Energy, Independence, and Global Warming. Not a fun experience, but part of your civic responsibility. If you're a scientist and you have information that is important to these issues, these critical issues of the size, rate, and significance of climate change, you can't be silent, in my opinion. And there are other extraordinary opportunities. Senator Ted Cruz went on Late Night with Seth Meyers and talked about the very satellite data that I just showed you. And he made incorrect claims about those satellite data. We tested those claims. We showed that Senator Cruz was wrong. We published a paper in the peer-reviewed literature, and that led to this opportunity to go on Late Night with Seth Meyers and set the record straight. And I'm just going to play a little clip from the end.
You remain optimistic, and I'm happy to hear that, but where are you finding optimism right now, considering the sort of deck that's stacked against you?
Well, it seems like a real teachable moment. Climate science has been elevated in public discourse. Look at that. Look at Senator Cruz appearing on your program making testable claims. The President of the United States saying nobody really knows the causes of climate change. And we do. So this is a moment when people are willing to listen. When I can come on your show and say, nobody really knows is wrong. It's fake news.
Yeah. I'm really...
So, what I want those teachable moments. I want to tell people, this is our understanding. These are the likely outcomes if we do nothing about the problem of human-caused climate change. And let's have a respectful, honest debate on what to do about it. But let's not dismiss this incorrectly as a hoax or a conspiracy. We all lose if we embrace ignorance with open arms.
Well, I couldn't agree with you more, and thank you so much for making the time. It's fantastic to have you here. Dr. Ben Santer, everybody. We'll be right back. That was great.
So, if you've got a voice, use it. Lesson 4. Extraordinary claims demand extraordinary proof. So back then in 1995, the claim that humans were affecting global climate was extraordinary. And I decided to bow out of the IPCC and decided that it was important for other independent teams of scientists to revisit the evidence and determine whether we were or were not right. This was from the most recent report of the Intergovernmental Panel on Climate Change in October 2013. Look at the difference between this statement and the balance of evidence statement. So these folks are saying, in 2013, 18 years later, we see the signals of climate change everywhere, in sea level, in snow, in ice, you name it. And they made this quantification. It is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century, where extremely likely had a specific meaning greater than 95% probability that the statement was correct. Here's another way of showing lesson 4. A friend of mine, John Cook, put together this timeline of the bottom line findings of the Intergovernmental Panel on Climate Change, from the balance of evidence to it is extremely likely that. So over time, the evidence has firmed up. We're looking at more aspects of the climate system. We have longer records. We're doing due diligence. We're looking at the sun. We're looking at natural cycles. And that's why the cautious, the balance of evidence suggests has firmed up over time. Another lesson was, don't just preach to the choir. Don't just speak to your peers. This is Bohemian Grove in the Redwoods in Northern California. The folks who gather there every year are sometimes referred to by the locals as the masters of the universe. So these are very, very wealthy people, and I had 30 minutes of their time. They were skeptical about me and everything that I do. But for 30 minutes, they had to listen to evidence. They had to listen to science. And what you try and do with those 30 minutes is give people pause for thought. What do you really want to be remembered for when you're gone? The amount of stuff you've accumulated or the good that you've done in the world? And if you had kids and grandkids, you have some investment in the future. What do you want to do to protect that investment in the future? So that's the hope, that in speaking respectfully to a variety of different audiences, you can shift the needle and truly affect change, as the Three Tenors are trying to do. The final lesson is declare values. So let me declare my values. I'm not just a climate scientist, I'm also a climber. Since I was 18, I've spent a lot of my time in beautiful, fragile, high alpine environments around the world. In the Alps, in the Himalayas, most recently in the Juneau Icefield, in the North Cascades. These are pictures that I've taken. And over one human lifetime, I've witnessed profound changes in these places. Chip has documented these changes in the stills and the videos that he showed you. They're real, they're happening. These changes do not just depend on satellite microwave radiometry or complex computer models of the climate system. You go to these places, you can witness them. So how do we value these things? What is the value that we assign to the Juneau Icefield? How are we diminished if we lose these places, if we lose the Great Barrier Reef? Let's have a discussion not only about the science, but also about human values and what it means to have these places. This is from this last summer. This is something called Heather Terrace, just below Camp 18 on the Juneau Icefield. I was there with Chip and Hernando. And at this location, since 2001, the surface height of this glacier, the Gilkey Glacier, has decreased by about 150 feet. Back in 1950, the Gilkey Glacier had no lake at its end, its terminal moraine. Now the lake is 5 kilometers long. These changes are enormous, and they're happening over our lifetimes. So without further ado, I'm going to thank you for your attention, and I'm going to hand off to tenor number 3, this very handsome gentleman here.
I'm going to introduce Dr. Hernando Garcon, but I'll tell you a little story before I do. I met Hernando, as I mentioned, in 2010, and I was on the board of an international NGO called Relief International, and the earthquake happened in Haiti. And as a board member, they knew that I was a person who had been a first responder, and I'd documented crises and human suffering around the world. And I'd been in Pakistan after the major earthquake there in 2006. I'd been in Darfur in 2008, documenting the genocide. So when the Haitian earthquake happened, I was at home in Milwaukee, and I was very busy, but I was at a point in time where I had the luxury of being able to say, yes, I'll respond, I'll go to Haiti. So I got down there about 35 to 40 hours after the earthquake, and already on the ground working for Relief International was Dr. Hernando Garcon. And I was thoroughly impressed with him, and the more I got to know about him, I understood that this is truly one of the greatest global health specialists on Earth. He's responded to more international crises than anyone on the planet. And so in putting this presentation together, what we've asked Hernando to spend some time with is to give you his background, of course, but also to look at how climate disasters are becoming more and more prevalent and requiring a lot of international medical response and international relief efforts. So Dr. Garcon works at Kaiser Permanente in California. He flew in last night with Ben. So without further ado, Dr. Hernando Garcon.
I wrote Chip's introduction notes in case you were wondering. And thank you all for being here and for still being here. And hopefully we can wrap this up and take some questions at the end of the talk. And so as Gail mentioned and as Chip mentioned, my specialty is emergency medicine. As my training, I finished my residency in 1992 and started practicing then. And at the time, the National Urban Search and Rescue System was forming as part of FEMA. After the Stafford Act in '89, FEMA became the federal agency that was responsible for responding to national disasters. And part of that was the creation of the Urban Search and Rescue System, which there's 27 teams across the country. They're housed mainly in local fire departments. So most of the 75 people that deploy on a team are firefighters that serve a technical or rescue capacity, but there are also 2 structural engineers that are civilian and 2 physicians that are usually civilians, and then 4 paramedics. And the job of the medical team on the search and rescue team is to take care not only of the rescuers, but also any victims that we're trying to save and take care of. The first deployment I did was in Oklahoma City in 1995. I've done 14 urban search and rescue deployments. The last one was a tornado in Kansas in 2007. I started doing international disaster response in 2002 and continue to do that to this day. And I have worked in civil unrest situations, earthquake situations, a number of things that are clearly not climate related. And so over the course of this career, I've really developed almost trial by fire an expertise around disaster response. But the other thing I've come to realize in the last 5, maybe 10 years is that I've also responded to flooding, to hurricanes, to typhoons, to famine in East Africa, to disease outbreaks. And many of those natural disasters have as a common thread climate change. And of course, all of those things happened before 20 years ago, 30 years ago, but as I'm sure you probably have a sense of already from reading the news and hearing stories, the intensity, the frequency, the severity of all of these natural events is getting worse, and the impact on humans has been worse. So I think the negative impacts of climate change are actually already with us, and I'll give you some examples. I want to give you some case histories of work that I've done, but I also wanted to do a couple of quick other slides and overview. I think if there's anything I want you to get from my part of the presentation, it's these 3 things. First of all, the World Health Organization has said that climate change is the biggest global health threat for the 21st century. And that's a pretty bold statement, and if you start to look at the numbers, you realize why. The other thing that I don't think most of us realize, unless you work and travel internationally and respond to these situations, is that the negative effects of climate change have their greatest impact on the poor populations, poor communities, poor cities, poor states, and developing countries around the world. And then the last one is that climate change effect on health will exacerbate the inequalities, and sorry for the typo, between rich and poor. So a couple of just overview slides. In public health sphere, we talk about the determinants of health. They talk about income and social status, education, physical environment, social support networks, just simple genetics that we can't do much about, gender, and the health services and access to those health services. And climate change affects some of these very directly and some of these indirectly, certainly your physical environment. But as you'll see, climate change will affect social status and income as well, will affect availability to health services. Who's at risk? It's pretty typical for most things. The frail, perhaps the populations that have less resilience, elderly, children, and people with pre-existing medical conditions. Diabetics need to refrigerate insulin. If you lose power in a disaster, what do you do about that? Dialysis patients need an infrastructure and dialysis machines that are working and clean water. So patients with certain medical conditions are much more prone to poor outcomes from disasters. The effects of climate change we talk about can be direct or indirect. Certainly temperature extremes. How many times do we read news about a cold freeze in the winter or an extreme heat wave in the summer when people who don't have access to air conditioning die because of the heat? Those kinds of things. Storm, flooding, drought, as you'll see in examples. And then indirect changes. Because of climate changes, the vector-borne diseases that are spread through mosquitoes, through ticks, when an environment changes and bats are more populous in Africa, the risk of Ebola goes up. 2 of the biggest Ebola outbreaks since it was first identified in the 1970s have happened in the last 7 years. So many of these indirect effects will cause health effects. I think this might be a little bit harder to see, but it's sort of a schematic of what are the changes in the climate and what are the potential health effects, right? So it could be things, if the first row is extreme temperature changes and how that affects it. You'll get flooding, you'll get storms. The middle one is the vector-borne diseases. Depending on where you live in the planet or in the country, you'll have different effects on health. So let's talk about some examples. Let's talk about the high precipitation events, and this includes flooding, storms like tornadoes and typhoons. I'm not sure if you can read from the back there, but this is a map published by the World Health Organization of the major flooding events from 2000 to 2010. Where is the laser here? And you can see the language that's put to these things. They say, worst flooding since the 1800s, worst in 70 years, most severe floods in decades. So it's not just 1 or 2 out of the norm storms that's occurring. The entire planet is being affected by this stuff. And this map just goes to 2010, right? It doesn't talk about Hurricane Harvey that dumped record amounts of rain on Houston. It doesn't talk about Hurricane Sandy that flooded lower Manhattan and turned power off in a place that you normally don't see a hurricane or a storm coming in. It didn't talk about the flooding and the rains in the Midwest that happened last month. This doesn't include the 2 typhoons that hit Mozambique in the same month, just in March. So these events have continued to go on, and they're more frequent. This happens to be a satellite image. You may have seen these in some weather maps. This is Florida. This is the Gulf Coast, right around here. And this is Hurricane Katrina. That made landfall, direct hit on New Orleans back in 2005. And at the time I was still working and deploying with the Urban Search and Rescue System. This is the first time and only time that we have evacuated a major American city. I don't think anyone would have thought that we could have had a natural disaster in the United States that would have been so severe that we would have to evacuate 500,000 people from one of the major cities in our country. There were many problems with that response. About 112,000 of those 500,000 citizens didn't have access to a car. So even though they called for an evacuation order, not everyone could get out. And again, this is a very good example about how the poor are more impacted than those that are less poor or not as poor. They did have a plan to get people that didn't have access to transportation out. It included using school buses to get them out. But the planning was so poor that those school buses were flooded by the time they were needed, so they couldn't get people out. And people ended up going to the Superdome and the Convention Center, housed about 30,000 people between the 2 facilities. And the effects of this disaster, and this is something that we don't often hear about or talk about, have been long-lasting. The population decreased 50% from before and after the storm. It has recovered some, but it's still only 79–80% of the pre-Katrina population. And for the poorer populations, the Black population in the city, it's still 30% lower. And there are about 100,000 people have essentially been permanently relocated outside the city. We'll talk a bit about why that's important. If you know New Orleans at all, you know most of it is below sea level and protected by levees. And the problem, of course, with this hurricane was that the levees broke. And when the levees broke and started to flood, essentially the entire city filled up, most of the entire city filled up like a bathtub very quickly. So we pre-stage before big hurricanes, news is coming, we're aware they're going to hit, it gives us some time to prepare. The National Urban Search and Rescue System was ready and was deployed immediately after. Actually, many of the teams were actually pre-staged outside the area to move in very quickly. We ended up setting up shop essentially at the edge of the water. We found that the New Orleans Saints training camp was not flooded and it was very close to the edge of the water, and that's where we set up these hundreds of rescuers to work. And this was one of the receiving points between the edge of the water and the dry land. And as you can see, there were many ambulances, there were buses all along the left, and it looks like chaos, and it was chaos for weeks actually. Many of the freeways are elevated in New Orleans, they're highways, and many people who couldn't tolerate the risks in the Superdome and the Convention Center, which got very lawless. There were actually stabbings, a couple murders, there were some rapes, there were fights all the time. It just got very out of control. So many people felt safer outside and on their own, so they just went and literally lived in a car on the high part of the freeway. And you can see, again, elderly, right? These are people who need assistance and have difficult time surviving on their own. So this is what an urban search and rescue team kind of looks like, and we would deploy small teams from the edge of the water into to go on boats and go and rescue people. Here's an example of using a local boat on the picture on the left there, and just grab people off of their rooftops or who were standing on top of their cars or whatever it was to get them rescued. We were doing hundreds of rescues a day, and I think in the first 3 weeks probably rescued close to 20,000 people.
The picture on the left is the scene of where we would rescue people to. So we would pluck them out of their houses or wherever they were trapped, bring them to a dry edge here on the freeway, put them down, and without a better plan, of course, we made calls and tried to get backup, but we said, you know, the buses will be here for you by morning to get you out of here. And unfortunately, because there were such delays in the response, what we realized was the buses weren't coming anytime soon. And so we'd taken these people that at least, even though they were in a flooded house, they could live on the second floor and they had a roof, and we were putting them out. Of course, this is August and New Orleans is still very hot with radiant sun. And we decided at that point for the first couple of days is to ship what we called, if you had three walls and a roof, we would give them the option to shelter in place. We know where you are, we'll bring you meals every day until we have a guaranteed way to get you out of here. And actually for a couple of days we ended up sheltering in place close to 3,000 people before we had the backup to pull them out to a safer location. Unlike the airboat you saw with maybe 15 rescued people and 2 or 3 rescuers, when you evacuate a nursing home, when you have people with high needs, it takes a lot of human resources, 2, 3, 4, 5 people to move just one person. It's much more laborious, and it takes a lot of time. So again, very at-risk populations that actually take a lot of resources to help as well. In the early days before the floodwater started to recede, you can actually see here the water line, right? The water's essentially up to the roof of the house. And initially the rescue is aimed at looking for living people. So we didn't do extensive searches. Anyone who was below the water line was likely dead and drowned. So what we did was cut holes in the attic spaces and go down and call for people and look for living people. As the time progressed and the rescue efforts diminished, the water level started to go down. You can kind of see the water level along the shingles of this house in the picture on the left. And then every house, every structure in New Orleans got searched at least twice. First was that hasty search looking for live people, and second was going back to look for anyone we may have missed, or even at that point just body recovery once the waters receded. This was the second to last gentleman that we rescued 18 days after the hurricane. He was a diabetic who survived on 1 gallon of water on his second floor. Needed dialysis, but he ended up recovering. And then this was the last person we saved on day 19, also a 37-year-old gentleman. So one of the big things that's not talked about or appreciated as much, and I appreciate this more now because I've seen it so much, are mental health issues that come up. And we think about deaths that happen from hurricanes and all this other stuff, and that's relevant and important, but I think the mental health impacts because of our unstable climate and the climate refugees that we have that get forcefully displaced is a very significant problem in these disasters. There have been several studies after not only Hurricane Katrina. I think the study started after Hurricane Katrina. They were also doing studies after Houston, Harvey, and others, but you can see the titles of 2 of these studies that were done after Katrina. Essentially, the conclusion is that displaced by storms, they experience loss of full-time employment, loss of income, deteriorating health, as well as struggle accessing the necessary health and mental care needs. They've shown higher rates of suicide, higher rates of substance use, higher rates of depression of the New Orleans evacuees that are not just in Houston, but in they went to Mississippi, they went to Alabama, they went to other locations. So this is 10 years after the event, and we're still seeing these long-term mental health and health consequences for these populations. So 12 years later, perhaps, you guys may remember Hurricane Maria because it was more recent. Here's the island of Puerto Rico in the center. Again, this hit as a Category 5, dead on the island of Puerto Rico. Essentially, no part of the island was untouched. Very devastating event. There were 3.3 million residents on the island. 98% lost power, lost cell phones. More than 70% of the structures were significantly damaged. All told, there were about almost 3,000 deaths finally when I think an accurate calculation came along. Similar to Katrina, $91 billion in damages. And 1 year after Maria, still you have close to 3,000 families that are still in housing that's temporary. Many of them are in Puerto Rico, but many of them are also in Florida and through 34 states. And again, very telltale, as we saw happen in New Orleans, about 300,000 have left the island with no plans to come back. That's 10% of the population. Right? I mean, New Orleans is still 20% of the population have been forcefully displaced and are not coming back. Again, whether it was from the wind damage or the amount of tremendous rainfall and flooding that happened, there was really no part of the island that wasn't affected. This is one of the poorest parts of America. The median income in the United States is about $48,000. On Puerto Rico, it's about $20,000. Throughout the 50 United States, about 18 or 19% of people are on Medicaid, rely on Medicaid for healthcare. On the island of Puerto Rico, it's about 49%. So those are really sort of poverty numbers that are like the poorest places in Mississippi or Louisiana. You can see here one of the big rivers, that you can see how high the water got. The water level got up to this road area, and you can see how this concrete bridge has been washed out. And so if you can imagine the kind of rainfall and volume of water flow that would take to create this damage, you'd start to get a sense of the devastation that this causes. We drove all over the island in our relief efforts, and you can kind of see the hillside. Every tree was denuded. Anything that was agriculture was lost, and all the trees on the entire island look like this. And that's a sort of an agricultural or an environmental recovery that's going to take a long time to rebuild. And again, no question these kinds of disasters have happened before, but they're happening with greater frequency, more intensity, and affecting more lives. This is what one of the clinics, so FQHCs are federally qualified health clinics that are partly federally funded to take care of Medicaid patients, people with low or no insurance. And there are 60 of those types of clinics in Puerto Rico. And while FEMA worked to support the hospitals and keep them open, which is a priority, it makes a lot of sense, I was working with International Medical Corps, and we were working to support these FQHC clinics throughout the island. We provided them with generators, we provided them with rebuilding material. They had plenty of doctors and nurses, most of those stayed on the island, but what they needed were the resources to stay open and to provide vaccines and to provide insulin for their patients and things like that. And then, the mortality of 3,000. So of course, where you are in the world and where you are in the United States depends on how you're going to be affected and what things you might face. Rising sea levels is going to get the coastal parts of the United States. Southeast, of course, is going to see the annual hurricanes with greater intensity. Out in Western California, we're seeing more drought. We're seeing more wildland fires because of that. Flooding and rainfall in the Midwest. So of course, it all depends on where you are. This is a graph published, I think, in 2014, and you can see that it's an estimate of the deaths in the United States and the billions of dollars because of natural disasters that have happened from 2004 to 2013. So if you go over here, heat waves, about 12,000 mortality deaths, tornadoes, almost more than 1,000, hurricanes more than 1,000. So over a 10-year period in the United States, these are lives lost that are attributed to all of these different climate events, and significantly higher in amounts than previous 10 years before that, or 10 years before that. And then the numbers as well, close to 400 billion from hurricanes, close to 80 billion from heat waves, close to 50 billion from tornadoes and severe storms. Again, my second point, and I think in the two examples that I gave for Maria and for New Orleans, you can see this, but climate changes have their greatest effect and their greatest deleterious effect on those who have the least access to the world resources, whether it's poor people in this country or in the next examples I'll give you about my international deployments, people in the parts of the world that have the least resources. Of course, the other part of this, I'll talk about that too, because I think it's important, if only at a moral level. They also are the people that are less the cause of climate change. So if we move from precipitation events to drought events, this is a picture from eastern Kenya. I did a response there in 2012 with Relief International for a large famine. This is a map like the other one I showed you, except instead of flooding and hurricanes, this is more about drought events. And again, as you can see, the language, devastating droughts from 98 to 2001, most severe drought ever recorded, of course, parts of Australia, severe and prolonged drought and here in South America, long-term drought in the Horn of Africa in 2005, and then when I was there in 2011 to 2013, over here in Canada, affecting agriculture, the driest growing season in 34 years, the wildland fires in California, 3.9 million hectares burned. Once again, if you look at the severity of these events over this time period, 2000 to 2010, it is significantly greater than the previous 10 years or 20 years. So the Horn of Africa famine in 2011, it was the worst drought that they'd experienced in 60 years. Over 9 million people were affected with food scarcity. And if you compare, and one of the things that I've seen globally, a developed country like the United States has good resources and they have resiliency, right? We build for earthquakes. We have levees for flood water. So when a disaster strikes the United States, you may see deaths in the hundreds or in the thousands for severe things, and then you see $1 billion in damage. When these disasters strike developing countries, you see the opposite. You see damages not in the $80 billion, but $80 million. But instead of 2,000 deaths, you'll see 200,000 deaths. And so this famine in this region that lasted for 2 to 3 years was close to 300,000 lives were lost because of that. Malnutrition rates for children reached 30% in parts of Kenya and 50% of southern Somalia and southeastern Ethiopia. We treated over 10,000 severely malnourished children in hospitals and clinics by international relief organizations that were working there. The definition of famine are when more than 30% of children are suffering from acute malnutrition, or when 2 adults or 4 children per 10,000 population are dying on a daily basis, or when you don't have enough food per person. And actually this area met at least one of those criteria for over a 2-year period. The other thing we saw, and we see this in famine situations, is when you're severely malnourished, your immune system essentially is non-functional and non-working. So one of the things that these severely malnourished children and adults tend to die from is actually infections. And so one of the things we commonly saw was measles in that case. And you know, you've probably heard there's been 700, even after having eradicated measles in the United States, there have been 700 cases here in the last year. Here we saw 17,000 cases for that 2.5-year period. So this was, I took a picture of this, a watering hole where because of the drought, villagers were having to walk up to 12 to 15 miles just to find a well that had water. They would come with their mules and they would load these jerry cans with water, almost come every day or every 2 days and do that 10-mile hike just to get the water. And this was one of the treatment centers that we worked in. I was working with Relief International. This was a child actually that was recovering and looked better than he did when he was admitted with severe malnutrition. And a mother with her baby. Climate change is with us. So one of the other things that we did was food distribution. Severely malnourished children you have to treat in the hospital. Moderately malnourished you can treat in a feeding program and just send them home with the food supplements and see them back every 2 to 3 to 5 days. The U.S. Agency for International Development is the part of the State Department that's the humanitarian relief side, and they provide most of the funding for this stuff. So this is what we would use to distribute food. Lovely people, amazingly appreciative of any help we gave them. So if we move on a little bit, I think I have one more example. So vector-borne and related diseases, essentially, as I mentioned, when you change climates, you're going to change breeding grounds for ticks, for mosquitoes that spread disease, and for other disease vectors. Things that we see in this country include Lyme disease. We've seen West Nile, we've seen Zika, we've seen chikungunya, which is in Central and South America, and come up here. In Africa, you'll see malaria, dengue, Ebola, other things. This here is a table or a graph of the changes in Lyme disease from 2001 to 2014. It's called Lyme disease because it was first reported in Lyme, Connecticut. So it's mostly, as you can see in 2001, an East Coast disease. But if you start to look how it's spreading through New York State, through Pennsylvania, and even in the Midwest now in 2014. Very much attributed to the change in climate and I was speaking to somebody yesterday who said even in the snow now you take a dog for a walk in this area in February or March, and instead of the freeze, having the ticks die off there around year round, and you can find ticks on your dog even in February or March. These photos are from a New York Times photojournalist who visited one of our treatment centers in Liberia when I worked with International Medical Corps to respond to Ebola. Ebola was first identified in the 1970s and basically had small outbreaks for 30, 40 years, and this one caught everyone by surprise. It really affected 3 different countries. There were confirmed over 11,000 deaths over the period of time. And this is the first time where something was big enough and happened in big enough population centers that people actually left the country with symptoms, not knowing they had it, or they got sick once they traveled outside the country, including Europe and including in the United States, as you probably heard. There was a fairly limited global response because Ebola is very challenging to work in. It has a very high mortality rate, and sick patients are highly contagious. And actually one of the biggest populations that ends up catching this and dying from it are the healthcare workers, unlike most other infectious diseases. So not many relief organizations found enough volunteers to go work in these environments, and there were really maybe 5 or 6 humanitarian relief organizations that providing medical care, and usually there's 20 or 30 for these big disaster events. Ebola treatment centers are essentially a single disease hospital, and they almost operate like an operating room in reverse, right? In an operating room, we want to keep the surgical field sterile to protect the patient. In an Ebola treatment center, you want to create that barrier to keep the infected patient from infecting the healthcare workers. And so that in 110-degree heat in Africa, you have to wear these head-to-toe suits. Working in these suits for 20 minutes, you wear rubber boots under the Tyvek pants. You will lose, you would come out of there with your boots filled with 4 to 6 inches of perspiration, of sweat. Frequently you would leave that and your core body temperature would be up to 102, and you'd lose several quarts of water just in working for 20, 30 minutes with patients. So a lot of water going in for the patients as well as the workers. It's a huge hygiene issue, lots of washing in water. And then the other challenging thing about this, of course, were the sickest patients and the ones that die are the most infectious. And so most people will actually get infected when they handle and try and clean the dead body or the very sick patients. And so we couldn't give the bodies back to families to bury them in their usual customary way, which usually involved a lot of body preparations and whispering messages to your ancestors in the ear of the newly departed, and they just lost that link with their ancestors and their loved family members. And so there was a lot of hostility from the communities towards the healthcare workers, very challenging. Not all bad. This was our first Ebola survivor, and we had several dozen in our 3 treatment centers over the course of this response. And so it does work sometime. Okay, a couple more slides. So climate change, I think this is important this has changed my perspective on the way I think about this, and one of the reasons I'm standing here talking to you and will continue to do so, and you'll see why. So this is these are called density cartograms, so you can see that the size of the country, depending on what you're measuring, what you're trying to report, the size of the country is changed in volume according to that measure. So this top one are the top carbon producers in the world from 1950 to 2000. And if you want the color-coded version, it's down here in the lower left. So the biggest producers, this is in billions of tons. The red is 35 to 57 billion tons of carbon. So by color schematic, it's the United States here, and you can see how big the United States is represented on that map. The next one is purple, so purple is China, Russia, and then you go down to the pink countries, which are the peach countries, which are like Africa. The reverse of that, so these are the carbon producers. The map on the bottom are the distribution of the 4 climate-sensitive health consequences. This is malaria, malnutrition, diarrhea, and inland flooding-related fatalities. So these are the countries that are most affected. You see how skinny the United States is versus how thick Southeast Asia and Africa are. This came out just last month, and I thought it was very, very illustrative. So, and the article was why the U.S. bears most of the responsibility for climate change. So this is the cumulative carbon dioxide emissions since 1750. This little video will start in 1850. So this is after the Industrial Revolution, right, in 1750. And of those first 100 years of the Industrial Revolution, the United Kingdom topped the list of carbon producers. And if you look, in 1850, that was 3.6 billion tons of carbon led the pack. And let's see what happens between then and now. So you see the year changing here. And you see the production, and watch how quickly this number starts to grow. So we're at 6 billion, 8 billion. And remember, this is cumulative carbon production. So right around World War I, we passed the pack. And we don't let go of the lead. Now we're getting to when some of us were born. Maybe not quite yet. Right, so more and more of us are starting to be alive at this point. Wait, that's me, that's where I was born. China comes into the picture. And if you're even a modest student of history, this makes total sense, right? In the prominence of countries and the wealth of countries that have happened over the last 50 years of our lifetime, or 100 years. Right here, 2018, look where we are, 400 billion. So we went from the UK leading at 3 billion to now we're ahead as a cumulative CO2 producer by 400 billion. So I think we bear a certain significant responsibility for that. So the other thing, going back to another health statistic, and I'm almost done. This is so mortality is obviously a measure of impact, but mortality is a kind of blunt measure. It doesn't tell us everything about health consequences or the impact on society. So one of the other metrics that we use in public health are called the disability adjusted life years, okay? So from the health economist perspective, 100 strokes that take away 180-year-olds don't have the same impact on society as 100 car accidents that kill 30-year-olds, right? Because those 30-year-olds often have a career, they had a contribution to society, they had children to raise, they had a family. So trauma surgeons will tell you this all the time. Even though fewer people may die of trauma than heart attacks or strokes, trauma deaths tend to be in younger people and have, from the health economist perspective, a greater impact on society as a whole. So one of the things that we look at are disability adjusted life years. And from that map, you can see the areas, these are disability adjusted life years that have already been lost because of climate change, published by the World Health Organization. And you see in the developed countries, which includes the United States and Europe, right? This is per million population, right? So yes, we had deaths in Katrina and deaths in Maria. As I mentioned, it's in the double digits, triple digits, maybe quadruple digits. But when you go to famine in Africa, and you saw that 275,000 died when I worked in the East Africa famine, you realize that the incredible disproportion of impact that climate change has already had on this planet. So this is from the same report that Ben has quoted, the IPCC report. Actually, this was from the 2013, 2014. But even this non-medical body, of course, it's a very extensive report, talks about the effect of climate change on health. I need to talk the details of that. And then just to give you a couple more numbers and talk about a couple more things. So the World Health Organization has estimated that 250,000 additional deaths per year will occur between 1930 and 1950 because of climate change from the various causes that we've talked about. And the other concept now, we're talking about climate refugees. So the World Bank last year produced this paper that said they predict 140 million people will be forcibly displaced from their homes because of climate. They even put numbers to that, how many from Africa, how many from Asia, how many from Latin America. The United Nations this year has increased that number to about 200 million. So when you think about those evacuees from Hurricane Harvey in Houston or Hurricane Katrina in New Orleans or Maria, and you spread that locally to where these events are happening around the world, that forced displacement comes with a very significant mental health and health price. So tackling climate change could be the greatest global health opportunity because of the potential risk. The United Nations, from 2000 to 2015, all the member countries of the United Nations signed on to the Millennium Development Goals. The replacement to those goals were the Sustainable Development Goals, and you can see here that many of these have some kind of implication or impact for the climate. All countries that are members of the United Nations are theoretically committed to sustainable cities, renewable energy, all of these things that have some significant impact on climate. These are the multinational legislative policy things that our leaders around the world are trying to do and make happen, the Paris Climate Accord and things like that. And then from the medical side, the Lancet is a British medical journal that actually puts a lot of focus towards global health and global health topics. And they have a list of recommendations with what health systems and public health systems can do to address climate change, establish a framework for strong, predictable, and international carbon pricing, invest in climate change and public health research, get more information about these impacts and ways that we can mitigate them around health. And then just the last slide with words, of course, individual, there's policy actions, there's individual actions. I think we all have to take this conversation seriously and think about how are we living our lives? What kind of planet do we want to live on? How can we each make a difference? Please talk to your congresspeople and vote. These guys put in a picture of the Juneau Icefield Site as well. And this also is from the Juneau Icefield. And yeah. If for no one else but our children. Thank you. Let's get these other things up.